Hello, everyone. I see y'all are coming in. So I'm going to start with a few housekeepings and introductions, and then we'll get into the meat of the matter. So for those of you who are new, this is the Grand Rapids 2030 District's weekly cannabis webinar series. We've had this going on for honestly about 2 months now, and it's not going to end anytime soon. So please mark your calendars for Tuesday at 3 o'clock EST for this very specific cannabis webinar series. So for this time, we're going to be talking about tweaking the margins, how controls set you up for a better yield and a leaner operating budget. We have today on the sponsor by Foresight. And Foresight is an incredible, valued professional stakeholder of ours of the Grand Rapids 2030 District. They've been a sponsor for a few webinars beforehand, but they honestly are phenomenal speakers, and I'm sure that you've heard them before at previous webinars that we've had as well. Foresight exists to champion energy management, accelerate sustainability, increase profitability for their clients. We've seen them be stars for building owners here locally, but I know that they've been nationwide since at least 2007. Foresight services currently touch over 2,500 facilities on at least an annual basis. But this knowledge, though, to me, it's a huge testament that they're able to keep the feeling of authenticity that we have when we work with them. And I'm sure that Surna can relate. So we're really grateful to have Foresight sponsoring. We're really grateful to have Brandy speaking today. Thank you, Brandy. So before we get into the directions, I always forget to introduce myself. My name is Jillian Gim. I'm the program manager for the 2030 district of the West Michigan USGBC. If you want to know more information, contact me. I'll get you all involved. But we're really grateful to have Brandy Keene, the co-founder and senior technical advisor of Surna, speak with us today. She's amazingly knowledgeable, and it's been such a joy getting to know her. But I want her to speak about her expertise today. So Brandy, without further ado, thank you so much for being here. Can't wait to hear you talk today. Thank you.
Oh, thanks, Jillian. Hi, everybody. Really flattered that you guys asked me here today, and I really, it's been great getting to know you, and I really like the work that your organization is doing. For those of you who don't know Surna or don't know me, my name is Brandy Keene. I co-founded Surna back in 2006, and Surna specializes in HVAC and dehumidification systems, specifically for controlled environment agriculture and cannabis cultivators. It's a long time to have been in this industry. We are ancient by cannabis industry standards, that is for sure. Industry looks a lot different now than it did when we were founded, definitely. Part of what we are doing, or what we have done in our own growth in the industry is as an adjacent service to our HVAC systems, is we've found that getting involved in controls was also really important to our business and to cultivators. So that is what we are here to talk about, is what can controls do for you? How can they help you make money? How can they help you save money? And what do they mean to your bottom line? And you'll have to forgive me, not being able to see the audience is a little bit strange as a speaker, because you don't know if you're getting, if you're giving good information or if you're boring the audience to tears. So I will try to be entertaining, and I will try to make sure that I get you information that you need. Obviously, if you have any questions, go ahead and send those in, and then we'll address them at the end. In the meantime, I will try very hard not to put you to sleep. So when we talk about controls in our industry, they really kind of touch on three different things, which are really distinct from one another, but kind of get tied up into into the same terminology, right? So you have controls, which is the enabling of critical functions in your facility, right? It is making things happen. Data collection is usually tied up very tightly with control systems. That data collection being collecting information that's relevant to those critical functions in the facility, right? And then you have the automation component, which may or may not be a component of your control system, That is the actual performance of those critical functions within a facility. So you have something controlling something, and then you have something that's actually doing the thing, right? Whatever that thing might be. So when we're talking about the things that we're controlling in a cultivation facility, these 5 components are the things that we are most commonly controlling, right? Our lighting systems, our HVAC systems, our CO2 distribution systems, alarming, telling us when something is wrong in the facility, and then our irrigation processes, which may just be irrigation or may incorporate some fertigation and nutrient dosing components as well. When we are looking at the types of control systems that are available to you, we've kind of broken it out into 3 categories, right? So in general, what controls are doing is removing the human element, right? They are automating certain processes to make sure that what's supposed to happen happens when and how it's supposed to happen, right? That has multiple layers of sophistication associated with it. So when we talk about basic or entry-level controls, what that really is turn it on, turn it off, right? At this time, these lights come on. At this time, these lights turn off. At this time, or when this event takes place, this pump turns on or this pump turns off. And then you get into more intermediate controls, which generally is going to have more data collection associated with it because it's generally controlling more things. And has the ability to do some modulation, right? And by modulation, I mean, instead of just saying I'm turned on or I'm turned off, I'm turned on at a certain rate or a certain volume, right? And then when you get into really advanced control systems, then we can get into full modulation, a lot of data collection, and even into some analytics of that data to help you build your business even better and make even more money. Now, it's important to know that every single one of these layers can help you make more money. So even the most basic of control systems is going to benefit your business if you choose to incorporate it. The amount you benefit is going to be, incremental to the sophistication and capabilities of those systems. When we talk about, like, you've probably heard the term BMS or a building management system. These are control systems that are very prolific in very large scale industrial applications, hospitals, airports, manufacturing. These are generally really sophisticated control systems that are operating these buildings, right? We don't see that very much in the cannabis industry right now. In fact, the vast majority of controls systems that are implemented in most cultivation facilities right now are generally the entry level systems, the turn it on, turn it off. One thing that I want to make a distinction about is the difference between a dashboard and a control system, right? So when you see a dashboard, or when you see someone, presenting their control system, what you usually see is their dashboard, right? What you're actually looking at is the information that this is collecting and giving to me, and where I'm able to set certain things, certain set points. It's displaying my room parameters. It's telling me if it's satisfied or if it's not satisfied, right? My temperature set point is 75 degrees. Am I at 75 degrees? Yes or no? So I'm satisfied or I'm not. These types of systems are generally great if you're just talking about turning lights on and off, or just turning a pump on and off, or just enabling or disabling CO2, for instance. And forgive me, I'm looking down at my notes occasionally. But when you start getting into really high quality HVAC systems or really more complex HVAC systems, they lack some functionality, right? They don't typically actually control the modulating functions of an HVAC system. They don't typically give you the ability to display or provide all of the relevant information about that system, or possibly even not be able to perform the full control sequence of operations. And by that, I mean, if we're measuring this leaving air temperature, then we need to modulate this valve in 10% increments until we are satisfied. You know, those sorts of things aren't generally provided by most front-end controls companies. And then, so what that means then is that often the manufacturers of those HVAC systems will actually provide you with those controls. And sometimes you might want them to talk to a front-end user interface that has irrigation, lighting, everything else on it. That's certainly possible, but the person who's providing you that front-end user interface, you need to make sure that they know what they're getting themselves into, because a lot of times they'll say, yeah, we can talk to any HVAC system. When the HVAC system wants them to pick up 1,000 points, and they're actually capable of picking up 10, right? So that's just something that is really important to understand about the kind of skeletons of control systems, and something that as you're discussing these with your possible providers, that you make sure everybody's on the same page, right? Okay, so now let's get into what you care about, right? Which is, how is this going to make me money? Because as much as we all like the social and you know, economic benefits for the world of cannabis, we also really care about the economic benefits for ourselves. And so let's talk about it from a lighting standpoint, first of all. So basic systems, entry-level systems. Obviously, removing the human element from remembering to turn lights on and off is pretty huge, right? And that's kind of an understood. But there are other ways that your control system can help you save some money as it relates to your lighting systems. The biggest one, and this can be done with a pretty entry-level system, assuming you have sufficient lighting panels and sufficient relays in the space to stage your lights on and off, right? So if you can use an entry-level system to turn lights on in a large room, for instance, spaced apart by 2 or 3 minutes, and then turned off spaced apart by 2 or 3 minutes, or 5 minutes, or 10 minutes, whatever, you know, whatever that you're comfortable with, you will reduce your peak demand for demand charges in your electric bill. So your utility provider is looking at not just how much energy you're using, but what the most energy you're using at one time is. And a lot of times those demand charges can be outrageously high. We've seen people who've managed demand charges and cut their bill in half by just getting rid of those penalties for that peak demand. That can be done with an entry-level system, assuming that you have planned for that in the beginning and you have enough relays for them to stage, right? The relay being basically the on-off switch, right? And so if you have 100 lights, but you only have one relay or one contactor, you are turning on all the lights at once. If you have 2, you could turn on half at once, you know, and so on and so forth. When we get into the more sophisticated control systems, then you can actually get into optimizing not just when the lights come on, but actually staging the lighting based on your PPFD, right? If I'm an early flower versus mid flower versus late flower, or I have X strain or Y strain, you know, what is the perfect PPFD in this particular situation? And how can I ramp these lights up or down based on that automatically, right? Generally, you're only going to want to do that with LED lighting, not so much with HID lighting, for a couple of reasons. First of all, when you dim LED lighting, the spectrum stays consistent. So even if I'm at a lower wattage, I typically still have the same spectrum. When you dim HID lighting and you change the temperature at which that light is burning, you are changing the spectrum. So generally, when you run an HID light that's 1,000 watts at 600, for instance, you are shifting some of the spectrum out of red and into blue. The other reason is because of that, the other option would be to kind of maybe checkerboard an HID light, but then you're getting really inconsistent PPFD across the canopy. So if we're trying to use a control system to dim our lighting to maintain only the PPFD that you need at any given time, you're typically only going to be able to do that if you're using LED lighting and not HID. HVAC, which is where I happen to know a little bit. just from my history, and you'll have to forgive me, the operating benefits of a sophisticated control system in an HID light or in an HVAC system, there's a lot. And I have a few slides. They wouldn't fit on one or two, so we're just going to go through it one by one. Basic systems. These are your really kind of straightforward, again, your on-offs, right? One, ensuring that your set points are appropriate for whatever your photo period is, right? Tell it what you want when your lights are on, tell it what you want when your lights are off, and it's managing that for you. It's automatically changing the set points. Depending on how much equipment you have in the room and how many fan coils or air handlers and how many compressors and that sort of thing, you can also stage equipment on. So let's say, just for instance, I have a 50-ton load in this room, and I've done that by putting 4 15-ton packaged rooftop units in to get me a little bit of redundancy. Well, instead of having them all come on when we call for cooling and having them all turn off when we don't need it anymore, maybe we turn on 2 for stage 1, and then a third one for stage 2, and then the fourth one only at stage 3. So that means that I'm not using more than I need at a given time. That gets me a little bit closer to the efficiency of a modulating system. It does not duplicate the efficiency of modulating setups, but it does give me a little bit more flexibility to get a little bit closer. And it also does the reduction in peak demand charges, right, when the HVAC system comes on. And then most entry-level systems have at least some ability to give you some kind of alarm. So I know if I am out of range for temperature, at least I can get a phone call or an email or a beep or something that tells me I've got a problem that I need to solve, instead of, walking in the room and discovering it then. So when we get into the more sophisticated systems is when we can really, really start to realize some big benefits. The first thing to note is that a really sophisticated control system that gives me all of this modulating functionality and all of this ability to observe what's going on with all of the pieces of equipment, it's only going to be really relevant if I have a relatively sophisticated HVAC system, right? If I've just got some rooftop units and some standalone dehumidifiers, those entry-level systems are apart from some of the data collection and maybe some of the more advanced alarming functionality, they're generally going to do just fine at controlling those systems. But when you start looking at what energy costs you, both for infrastructure, meaning what size is my power upgrade, how many amps do I need to this facility, and then how much energy I'm using, you really should take a look at some of the more sophisticated, HVAC systems. Longevity, there's a number of reasons to do that. The primary function of these more sophisticated systems is the ability to modulate everything, right? And so I might have a total of 50 tons available to me, but I can modulate every component of those 50 tons to just have exactly what I need, exactly when I need it. And so that means never using more energy than I absolutely have to use right now. That also means automatic switching, back and forth from if you're using chilled water, from a water side economizer, or if you're using a hybrid water-cooled condenser, right, switching back and forth from water-cooled to not. A lot of things that can be modulated to maximize output and minimize energy use. The analogy that we use a lot is setting cruise control versus stop and go traffic, and how your gas mileage is just far higher when you're cruising at 55 on the highway. Well, okay, let's 75 on the highway, or stopping and going and stopping and going. And it's actually even worse than that. It's really more like flooring it and then slamming on the brakes, and then flooring it and slamming on the brakes. If you can modulate all of those components, you will use less energy. The other benefit to that is the ability to get extreme precision in the parameters that you're setting. So the reason for that is, again, the modulation of everything to only get exactly what you need at any given time. So when you're just turning things on, turning them off, turning them on, turning them off, your controls trend line, right? Or if you're looking at your data and the performance in the room, it looks like this: up, down, up, down, up, down. Because what happens is it says, okay, my set point's at 76 degrees Fahrenheit, or my humidity is set for 55 degrees. So it doesn't come on until that's out of whack. And then it doesn't turn off until you bring it down, right? So it drifts out, comes back, drifts out, comes back. Where when you have a modulating system, as soon as it starts to move off of the set point, the modulation starts to adjust, right? It starts to address that it's drifting out. So then your trend line looks a lot more like this when you're looking at what those parameters are. So that volume, or that amount of precision, allows you to really dial in a process for your cultivation operation, right? I mean, this is a version of manufacturing. So it gives us a repeatable process. If I had X results from, Gorilla Glue or whatever strain I'm growing right now, and I want to replicate that over and over and over again, well, the best way to do that is to make sure that I'm doing the exact same thing every time, and deviating from what I did last time the least amount, right? The multiple sensors, there are actually some entry-level systems that can actually accommodate this. So this isn't just in the more sophisticated systems, but it is kind of an upgrade, we would call it, right? And what we're talking about is, and you'll see these zones in the screenshot, being able to see not just what's happening in one part of the room, but in as many parts of the room as I would like to see. So you'll see this one is fairly consistent, but we've got one zone that's about 1.5 degrees cooler than another zone. Well, that would tell me that that maybe I need to adjust airflow in that room a little bit, right, to get a little bit more homogeneity. And then the way that your control system is controlled in response to those sensors, you can also change. For instance, you can tie specific equipment to each sensor in that zone. So you can say that essentially zone 1 operates independently of zone 2, which operates independently of zone 3, which some people who maybe are growing different strains, multiple strains in one room, might like to do. Or you can have your HVAC system all tied together and operate based on the average of all of those sensors. And so it just gives you some flexibility in how you operate your systems. This is where I think that really sophisticated control systems give you enormous value. And this particular screen, and I wish it was a little bit bigger. Hopefully you guys can zoom in on it. This is telling me what is happening with every chiller, every condenser, every pump, every boiler on this system. It's telling me that it's enabled or disabled. It's telling me, at what volume of energy use it's using, right? Or what, how much percentage of its capacity is in use at any given time. This gives me so much information about how my system is operating, right? And that means I know if something's potentially failing. I know if something is maybe using more energy than it needs to use, which would tell me maybe I need to do some maintenance on that system, before there's a bigger failure. It tells me if something is broken before it results in an alert in my room, right? So generally you'll have an alarm that says, hey, your room's hot. Well, this will give me an alarm if I have a piece of equipment that's failing before my room gets hot, so I can potentially address it before I have a problem, right? Which can save me quite a bit of money. This is a continuation of that previous page. It gives me some information to do some operating adjustments, right? So I can actually look at it and I can say, well, if I modify this irrigation schedule slightly, right? I see I've got this little spike in energy use right here. Maybe I can take 5 minutes longer to do irrigation and get rid of that little spike in use. And then, as everyone who's ever built a new facility knows, there's a lot of dial-in a new building, right? You don't just build a new building and put plants in and everything's perfect. Nobody who's ever built a cultivation facility would tell you that that's the case. Being able to access all of that information through your control system gives the team that is dialing in your HVAC system so much information on how to really perfect the control sequence of operations and make minor adjustments from anywhere to make it just really dial it in, both on how much energy it's using and on how it's performing in the facility. So just really good info there. All right. So the rest of the facility, the other things that control systems are operating in most grows and how they help you. The CO2, I think it's pretty straightforward, and I don't think it's really vital to have a system that can modulate your CO2 valves. Automating the delivery of CO2 to your room to make sure that it stays, between 12 and 1500 parts per million, or 8 and 1200 parts per million, or whatever that is. Obviously, making sure it doesn't get too high, making sure it doesn't get too low, and then making sure you have the appropriate alarms, which your fire department's going to require anyway, right? You could do some modulation to, instead of saying, well, it comes on at 1200 and turns off at 1500 and it stays at 1400 all the time. You could modulate CO2 valves with a more sophisticated system to achieve that. I'm not sure that it has enormous benefit, except maybe, after the lights go off to make sure you haven't overshot what you absolutely need. But it is something that's doable. Alarms. So your basic system is going to tell you when there's a problem, a predefined problem in the cultivation space, right? Whatever you've discussed with your controls provider, they've got sensors in there. Whatever sensors they're using or whatever they're reading, once it gets out of a certain range, you want to know about that, right? That's usually temperature and humidity. Ideally, if your temperature gets out of whack, you have an overheat shut off for your lighting, right? Where you can either dim those lights or shut them off in zones until you can get in there and correct the issue. And then more sophisticated systems, we kind of touched base on this a little bit before, but understanding when something's wrong with a piece of equipment before it actually impacts the facility keeps things from being an emergency. And then being able to maintain them, ahead of a potential failure can really improve the longevity of that equipment. I mean, you should be on a quarterly or weekly or monthly or maintenance schedule, depending on what type of equipment you're using anyway. But seeing a problem before it becomes a disaster can help you, to avoid some of the more costly repairs in some of these systems, particularly on the HVAC side, but also on, irrigation and a number of other things. This is an example, a screenshot of an alarm where we actually, there was something wrong in the space, but, we might have been able to get ahead of that with a more sophisticated system had we, had this particular client implemented, level 2 on this type of system, so that we could go and address that before it was a problem. Irrigation and fertigation. This is the most commonly automated process in a facility, and for obvious reasons, right? It's extremely labor intensive, and if somebody forgets to water a plant, it's a pretty big problem. And there's some variance in how it's addressed. Sometimes it's on a timer. Sometimes it's measuring the EC in a Grodan cube. And just replacing all of the water. And then there is a difference between your irrigation and your fertigation, which I'm sure you guys are aware, right? You have your dosing to get to a nutrient mix, and then you have the delivery of that nutrient mix to the plants, right? So the delivery of the nutrient mix to the plant is the thing that we see most commonly automated on some level. But when you start stepping up sophistication, I mean, you know, most of us watch nutrient water run down the drain in our irrigation system. Well, you know, if irrigation timing or delivery of nutrient water could be based on moisture content or on a specific nutrient deficiency as opposed to just replacing all of that water, well then, you know, you can reduce the amount of nutrient that you're using and you can reduce the amount of runoff associated with that. So analytics is not a component of most controls systems. And when analytics are automated, it is generally a separate company managing the analytics that is talking to your control system to, or whatever form of data collection you're doing. Whether you are manually reviewing data or whether you have some kind of automated analytics, it is utterly pointless to collect all of this data unless you are analyzing it and using that information to propel your business forward, right? So revenue and yields, right? That's a very basic, you know, component of analyzing your business, right? I want to know how much money I'm making. I want to know what yields were with specific strains. That's going to help me decide what strains I'm keeping, which strains I'm dumping. But I can go deeper, right? I can use my test room and utilize analytics to manipulate, you know, we were talking earlier about manipulating PPFD to optimize it to certain, just you know, certain times of your plant maturity. Well, how do I know what that is if I'm not going back and looking at, you know, how my plants are performing? And then understanding correlations between events that you might not otherwise connect, right? So what happens if, you know, let's say week 3 of flower, you had, you know, one anomalous temperature event, right? And then at week 9, you happen to have either an abnormally large harvest or an abnormally low harvest or a higher quality or a higher THC content. No one's going to remember that 6 weeks ago we had one day where it got 5 degrees out of set point. But if you've got those analytics to go back and look at, then you have something where you can go, hey man, you know, maybe we were onto something here, right? Or, ooh, let's make sure that never happens again, right? And is it going to give you some magic recipe that triples your yields and gets you, you know, 35% THC on every strain? No. But any amount counts, especially if it doesn't cost you anything to make a slight adjustment, right? We kind of talked about this, right? Reviewing anomalies. You know, see if it happens once, look at it again and again and again, and anywhere you can put those pieces together to identify patterns. Perfecting those processes, right? Yields up, consistency up, getting that process down to a manufacturing process for every single time we do it this way, and it never changes. And without constantly analyzing that data, how do you perfect that process, right? And we've all been there. Surprise good harvests, surprise bad harvests. You know, well, gosh, you know, last harvest this thing was 22% and now it's 17. Like, what happened, right? That data is going to tell you what happened because nobody's going to remember. And sometimes, you know, the staff may not want anybody to know, right? So that reporting and analytics is just going to be super important. This is just another screenshot, not telling you guys anything you don't know, but this is the kind of information you can collect as it relates to your HVAC system in particular that will help you with those analytics down the road. Again, you know, perfecting control sequences, perfecting energy use, you know, all of those things that will reduce the amount of money that you're spending to grow cannabis. So, that is all I have. I'm happy to take you guys' questions when Jillian takes over. You'll see my colleague Levi Lilly's contact information here. Levi is actually local to you fine folks, and will be extremely responsive if there's anything at all you need from us, and then he'll always loop me in if you need me. So, thanks, guys.
Thank you, Brandy. I feel like I want to keep the sound bits from that last stuff you were saying. That was gold. And Levi's great, honestly. He's been at expos here locally, and he's a really charismatic guy. So don't be afraid to ask me or Levi any questions you guys have. So we have some questions coming in like consistently throughout the throughout your presentation. And what do you want? Chronological? You want
whatever works. Chronological. Yeah, let's do chronological. They've been waiting the longest.
Okay. So from like 309, it says, why do you think indoor agriculture is late to the game on BMS?
So say that one more time.
Excuse me. Why do you think indoor agriculture is late to the game on building management systems?
Ooh, that's a good question. Money.
Really?
I think that's a big part of it. You know, folks are always unpleasantly surprised how much it costs to build a cultivation facility, and that I think is one of the components that folks see as something they can cut out of the budget, right? Because it's not, although it's enormously beneficial, it's not absolutely critical. I can grow plants without it. I can go turn on a switch without it. You know, so when folks start having to cut the budget, that's you know, probably something that that is early on. Now that said, one of our focuses has always been to make this affordable, and that's been the HVAC systems we designed. So what we're talking about is practical applications of this stuff, right? No bells and whistles that you don't need, but everything that you do need in an affordable price point. So I'm starting to see that change. I'm starting to see people really understand how valuable these control systems can be. And then I'm starting to see the industry kind of respond and go, hey, you know, how do we get folks to adopt this stuff by making the price palatable? We're also seeing, you know, investment increase. You know, the average cost of a cultivation facility, that what people are spending now to build them versus what people spent 5 years ago to build them is a pretty big jump, right?
Yeah, absolutely. I think that segues really well to this other point that came down a little later. All it says is exactly, like exclamation point. How can controls help with scaling? I think it's segued well, so I'm gonna jump down real quick.
Yeah. Well, so you know, when you're talking about scaling your business, right? One of the things that's so important is understanding the existing business, right? And what do we need to do to get better? What do we need to do to what do we need to copy as we get bigger, and what do we need to stop doing as we get bigger, right? So that data collection and analytics part is just so important, right? And then, you know, minimizing the amount of labor in the facility, minimizing the amount of manpower that you need as the facilities get bigger and bigger and bigger. Those processes need to be automated more and more and more and more, because you know, otherwise you're adding people and adding people and adding people and adding people. When you look at your infrastructure in a facility, if scaling or growing the business, building a, you know, expanding into the same building, building a building next door, if that's part of your long-term plan, make sure that your engineering team understands what your long-term plan is, and that your controls team understand what your long-term plan is, because it can help you understand investments you can make now that will dramatically reduce your long-term costs, right? And so just to put that like in terms of HVAC systems, for instance, you know, if we can build a bigger plant outside that is capable of ultimately running a larger building, if there's money in the phase one budget, it'll be a lot cheaper than trying to add to it when we get to phase two. And that's just one example. Wastewater systems, you know, wells, if you're digging wells, you know, all of those kinds of things. Sorry, that's a little bit of a segue from control.
No, it's great. It's great.
But you know, from a control standpoint too, make sure everyone involved knows what your long-term plans are, and make sure that you guys have talked about what that expansion plan and scaling plan looks like. Because you know, good engineers will help you identify areas where you can reduce CapEx.
Yeah, for sure. So it seems that like you were speaking to when controls are being used at the very beginning of scaling. Do you ever see that like folks in their phase plans decide, well, after this crop, then I'll add controls. Do you see that ever happen?
We do. We find that people recognize that they should have implemented controls all the time. And sometimes you can't avoid it, right? I mean, there are some, again, particularly in irrigation systems and in the more energy efficient and more sophisticated HVAC systems, you have to be able to control them, right? And so, but even on you know, the lower sophistication systems, you'll find folks going, man, I wish that I had known then what I know now. Retrofitting anything in an operating facility, whether it's controls, lights, HVAC, irrigation, anything, is exceptionally difficult, right? You have got to be prepared to shut down parts of your production space for at least a period of time, right? And to minimize that, it has to be incredibly well coordinated. But implementing a control system, it requires a lot of wiring, right? It requires some dial-in. And so, you know, let's say that today you're operating your air conditioners on thermostats, and tomorrow you want to turn on the control system. Well, you got to turn on the control system, and then you got to do point-to-point checkout of your wiring, and then you got to make sure that everything's doing what it's supposed to do. So you've got to allocate some days for that, right? And so if you are planning on a later implementation or a later retrofit, just know that implementation is not going to be seamless. But if you're working with someone who knows what they're doing and understands, you know, the ins and outs of your facility and the unique difficulties of the cultivator and what you're trying to do, then they can certainly help you minimize that downtime.
For sure. And sometimes folks are like, they only can do with the cards they have, right? And if they don't have the capital for controls right now, then from obviously what you've said in your presentation, there's ways to make a basic work, a more sophisticated work, even more sophisticated. Actually, that's one of the questions. What is the difference, probably in a nutshell, I assume, what is the difference between basic, sophisticated, even more sophisticated systems? That was the next chronological question.
In cost?
This was at 320, so probably around the time you were talking about different HVAC equipment.
Okay. So if we're talking about different HVAC systems and the cost of like an entry-level HVAC system versus a really sophisticated HVAC system, you can get up to, you know, depending on, again, and one of our jobs is to talk about them in every option and really review the budgets and the pros and cons of every type of system, because you can make a lot of stuff work. But anywhere, you know, from the worst to the best, probably 4x cost difference. But that's just when you are looking at that system by itself. When you start taking into account how much lower your electrical infrastructure has to be, for instance, and that shaves an enormous amount of cost off of the whole building, right? You can't look at it as its own element. You have to look at it as far as how it affects all of the other construction elements. If the question was more around the controls systems, it really depends on who's supplying that system. I mean, we've found that we've been able to implement our control systems, which I would put it, level 2 to 2.5, at a price that's very similar to what we've seen level 1 control systems implemented at. That's just us, right? There are variances from everyone who supplies these, and frankly, not everyone's capable of doing a level 2 or a level 3, right? And that's something to really explore and understand. It was why I was kind of saying, make sure everybody really knows what they got to do, right? Don't buy a dashboard and think you have a control system, because it's not the same thing.
That's perfect, Brandy, because I'm reading through questions, and Casey here locally has a question that aligns really well with literally a question that was of the next chronological order. So I'm going to combine them together a bit. He asks for recommendations on HVAC manufacturers that work best with controls and data analytics. The question up here said, what should I look for? What should I look for to make sure a front-end dashboard can actually communicate with an HVAC system? So could you maybe combine those two questions in your answer?
Sure. So for the question around HVAC equipment and manufacturers, you can make
that work best with controls and data analytics.
Yeah, so you can make nearly anything work, but the ones that are best for the higher sophistication control systems are generally going to be, either 4-pipe chilled water systems or some type of hot gas free heat systems, which are modulating. They have integrated dehumidification. So your temperature and dehumidification management is in the same set of equipment. But then there are options within options within options for those things, right? But generally, integrated cooling and dehumidification is going to be a higher end HVAC solution that's going to be, you're going to be able to get the most out of a control system that's really detailed, right? Can you read the second question again?
What should I look for to make sure a front-end dashboard can actually communicate with an HVAC equipment system?
So your controls is generally spoken in 2 languages, BACnet or Modbus, right? And the front-end user interface will connect to the HVAC controls using one of those 2 languages, right? Generally, the HVAC equipment can be provided in one or both. So the first thing is to make sure that they're both speaking the same language, right? Do I have BACnet or do I have Modbus, and are those 2 compatible? Because it's either one or the other. It's not going to be both, right? A lot of HVAC companies will be able to do both, and then just rely on whoever's providing the front end interface to tell them how they want the information. But then the second is to make sure that the folks who are providing you the dashboard don't just think they're giving you some temperature and humidity set points, because that's what they think of as controls, right? They need to be able to pick up, I made reference to this. They think they're picking up 10 BACnet points, and the HVAC system needs them to pick up 1,000, and they go, whoa, this is not what we signed up for. It literally just happened with one of our clients.
Oh, wow, really?
Yeah. And so the best thing to do is to either utilize the front end interface of the most sophisticated of the companies, right? So they can either pull in the other company's data or vice versa. B, get your HVAC engineer on the phone with whoever you think you want to use for controls and have them talk very early stage. And then make sure that your HVAC provider is comfortable that the folks providing that dashboard are competent, to pull in all that information. The other thing too is you can always utilize 2 different dashboards. right? If you really like company A because of how they manage irrigation, but they're not capable of managing the HVAC system the way that you want to manage it, you can always have one dashboard for the HVAC system and then another for everything else. Because unless you're doing extreme analytics, you know, minor convenience is probably a good trade-off for functionality.
That was an excellent answer. I'm sorry. Was there more to that? Because oh, okay, that was great, Brandy. That was great. So Joel asked, I know that this may change significantly depending on the size of the grow facility / rebates / type of systems, etc. But is there a typical payback period expected when a sophisticated BMS is installed?
Ooh, that is, I mean, that's a loaded question because there are so many variables. While you're very right, that, you know, everything from the size of the facility to the level of sophistication, you know, if it means the difference between a crop lost and not, it's, you know, a good building management system can pay for itself in one crop in that case, right? Also, when you think about it in terms of the maintenance, you know, if you have something that's beginning to fail and can be saved before it fails and there's some kind of catastrophe, well, that, you know, depending on the size of your facility, I mean, that could mean hundreds of thousands of dollars potentially in not having to replace certain components. Dialing in and improving yields by 1 or 2%, right? I mean, that's a math problem for what 1 or 2% means in revenue versus what the control system costs. You know, I think of things always in terms of HVAC systems because frankly, it's the most complicated thing to control in these facilities. And generally, you know, we see that the sophisticated controls cost between 10 to 15% of what the whole HVAC system costs. So if you're investing $500,000 in your HVAC system, you know, expect to spend something like $75,000 on a sophisticated control system. But, you know, like I said, apart from the 1 or 2%, you know, improvement in yield, also consider, you know, what it can do from an energy use standpoint. And those peak demand charges being one of those things, right? From utility provider to utility provider, those peak demand charges change. But your electric bill is going to be, you know, top 3 of your recurring monthly expenses, if not the highest recurring monthly expense that you have. And if you can utilize a good control system to help you manage that, that can be a huge chunk off of your bottom line. So I could throw, you know, 1 to 5 years at it, and I know that's a huge range, but there are just so many variables. And then, like I said, if it saves you from losing 1 crop or saves you from losing 1 piece of equipment, it is paid for itself in an instant.
Yeah, that's true. That's true. There was this question, and this will probably be the last question before the end of the time, or maybe we can fit 2 in 1. In a quick sentence, what is the definition of modulation?
Modulation is making incremental changes in something's output to ensure that its output directly matches the load. Hopefully that was clear.
That's really fair. Anonymous attendee, if you want to talk more about that, circle back with us, all right? I think this is great, Brandy. So this is a little longer one, and this will be the last question of the day. For folks in the call, if you have follow-up questions, I'll talk about that in 2 minutes. So it says, thanks for the information about saving money and eliminating human risk. Do you have a case study stats about factors like yield quantity improvements, reduced pests, or reduced labor hours?
That's a really great question. We have not done any direct case studies with our clients, but I'm sure I could find you some. And in fact, we're connected to a few different groups that are actually involved in doing some case studies right now. So circle back with Levi, and we'll see what we can dig up for you.
Perfect, perfect. Would you mind going to the next slide real quick, Brandy?
Do what?
Would you mind going to the next slide real quick?
Oh, yes, sorry, thank you.
No, thank you. So folks on the call, so if you do have more questions, you know, if this was an interesting conversation for you and you want to know more, you'll see that there's a survey going to come out to you soon with the recording of this webinar, as well as the slides that Brandy's provided. And so you'll see that survey is embedded in the email. Fill out that survey. It's very important to us. This is how we got Brandy here in the beginning, because you guys wanted to know more about controls. So fill it out, let us know what you thought, and let us know what more you want to see. And if you do have a follow-up question, send them our way, and we'll make sure we can get that answer for you. So mark your calendars, as always, for Tuesday, 3 to 4 EST, and we'll be answering the topics that you guys expressed that you were interested in. So thank you to our visionary sponsors for always supporting us, and thank you, folks, for always being here in attendance. Foresight for sponsoring, we're forever grateful for you. And lastly, Brandy, thank you so much for your expertise today and volunteering your time to speak with us.
Oh, it was fun. I appreciate you having me. Hopefully nobody fell asleep.
No, I think everyone stayed awake.
Hey, real quick, Foresight, we've worked with those guys for on a few things, and they're pretty awesome. So I just little
plug. Oh, and congrats to Mike. He just had a baby this week. Well, Jerry's wife did. So everybody give Mike congratulations. Thank you, everybody. I hope to see you guys next week.
Bye, everybody. Thanks.